All right, one more look at piecewise functions today. This time I'm going to give you a piecewise graph, and I want you to be able to make the graph, okay? So we're going to do a couple of examples here together. So first of all, we're going to start with one function at a time. This function here is defined by two different pieces. We're going to start with this one right here. You can see that it's going to be a line. It's already in point slope or slope intercept form. So I can see that if I were to graph this, it would cross, and I want you to do this in pencil, by the way. So if you have a pen, stop and get a pencil because you're going to need to erase, just so you know, okay? So on that graph, I can see that it crosses the y-axis at -5. Its y-intercept is -5, and its slope is 5/2, which means I go up 5, 1, 2, 3, 4, 5, and right 2, and up 5, and right 2. So if I were to draw that line, it would look like this, okay? The problem is that that line doesn't exist on the entire graph. That line only exists when my x values are greater than 2. So I'm going to go and I'm going to find my x value of 2. Here's my magic spot right here where my x value is 2. And that line only exists when my x values are bigger than 2. So now you need to decide, are x values that are bigger than 2 to the right of that magic spot or to the left of that magic spot? And bigger than 2 would be to the right of that magic spot. So that's where it can exist, and I have to erase the rest of it. So I'm going to erase all of this, and it can only exist when my x values are, oops, not exactly 2, sorry. There's going to be an open circle there because this is not underlined right here, and then it's going to look like that. Okay, so there's the first piece of it. And then the next piece of it is right here. Notice it's just like having the equation y equals -1, which is a horizontal line at -1. So this is what that entire line would look like, okay? But again, I have to pay attention to this, and it only exists when my x values are less than or equal to 0. So here's my magic spot where my x value is 0. And it can only exist when my x values are less than or equal to 0. So you're going to have to decide, are your spots that you get to keep to the left of this magic spot or to the right of it? And if it's less than, it's to the left of it. So I have to erase all of that, and that's what the graph would look like. Okay? So now I want to be able to define its domain and range. So let's start with the domain, okay? And I'm going to look at where is my graph touching this, okay? So I'm touching right now, I'm touching until I get an x value of 0. And then I don't touch again until my x value hits 2 and bigger, okay? So I'm going to start in interval notation. In interval notation, it goes from -infinity until I hit an x value of exactly 0 because it's closed in. And then again, so from -infinity till exactly 0, and then again from almost 2, so a parentheses at 2, until I hit positive infinity. Okay? In set notation, it would look like this. Set of all x such that x is less than or equal to 0, or x is greater than 2. All right. And then the range, we're going to go the other way. So I will graph or draw a horizontal line, and I will drag that, and I'm not touching, I'm not touching, I'm not touching, I'm not touching. Right here, I'm touching, and that's when my y value is exactly 1. Okay, all my y values are 1. Right here, I am almost touching when my y value is 0 or bigger. Okay, again, range, you look at y values. So your y values are -1, and then it doesn't touch again until it hits 0 or bigger. Really not 0, but bigger than 0. Okay, so in interval notation, it would look like this. It goes from -1, and then again from 0 to infinity. And in set notation, it would be set about y such that y equals -1 or y is greater than 0. All right, a couple more along with some review here. This first little piece has a equation y equals negative x. That means it has a y-intercept at 0, and its slope is negative 1. So I go down 1, right 1, down 1, right 1, and I draw that line. Or, of course, instead of going down and to the right, I could go up and to the left. Again, that line only exists when my x value is at negative 1 or smaller. So here's my x value of negative 1, okay? And it can only exist when my x value is smaller than that. So I'm going to have to erase that, and it will look like this. Smaller than negative 1 would be to the left of it, okay? Then I have another piece whose y value is negative 1. So that would look like this. But that only exists when my x value is somewhere between negative 1 and 2. Notice at negative 1, it's an open circle, so I'll have an open circle at negative 1, and it will be closed at 2. So it should look like this. The rest of it has to be ditched. Okay, and then I have another one whose slope, or whose y-intercept is at 5, and whose slope is negative 2/3, so down 2 and right 3. Down 2 and right 3, it would look something like this. Okay, but that can only exist when my x value is greater than or equal to 3. So notice it's not underlined. So when my x value is 3, here's where my x value is 3, I'm going to have an open circle. It can only exist when my x values are bigger than 3. So you need to decide, is that to the right of that magic spot or is it to the left? And it is to the right of it. So the rest of it has to get ditched. Okay, so here's what my graph would look like. And it's increasing where there is positive slope. And I don't have anywhere where there's positive slope here. It's decreasing where there's negative slope. And the red piece has negative slope. Okay, and I should make that arrow there. I think it got erased. My decreasing goes from negative infinity. This is an interval notation now. It goes from negative infinity until my x value is negative 1, and it's a closed circle, so I'll have a bracket. And again, when my x value is 3 to positive infinity. Okay, and I know that some people are going to call this negative infinity because it goes down, but you describe it with your x values. You're moving to the right, 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 so your x's are approaching positive infinity, even though your y values are getting closer to negative infinity, okay? Same thing on the other part of it, opposite on the other part, okay? And then that would be in interval notation. In set notation, it would look like this. Set of all x such that x is less than or equal to negative 1, or x is bigger than 3. Okay? And then in the last part, what is the maximum value? The maximum value is the highest point that that graph ever reaches, and this line is going to keep going up and up and up and up and up and up and up, so it will reach positive infinity. And the lowest point ever that the graph reaches, again, this section is going to continue going down, so its minimum would be negative infinity. Okay, and one more quick problem here. We have this little section here. So first of all, we have a line whose, or an equation whose slope is negative 3 and has a y-intercept of 0. So y-intercept of 0, slope of negative 3 means it will go down 3 and right 1, or up 3 and left 1. Okay, and I would connect that. The problem is that that only exists when your x value is 0 or smaller. So my magic spot is when my x value is 0. And then I have to decide, would ones that are smaller than that be to the left or to the right? And the smaller ones would be to the left. So that has to get ditched. Okay. And then I have another one who also has a y-intercept of 0. However, it's not underlined. So I'm going to make an open circle here because it's not underlined. And it has a slope of 2/3, which means I go up 2 and right 3, or down 2 and left 3. So it would look like this. But that only exists when my x values are between 0 and 3. So I already have the 0 on there. Here's where my x value is 3. And I get to keep anything between those two magic spots. and everything else has to get ditched. And then lastly, I have a horizontal line of 3. So it will look like this, except for that only exists when your x value is at 4, open circle, or bigger, okay? And bigger than 4 would be to the right of that magic spot and not to the left. So this is what your graph should look like. And then the last little question is, does this function have any points of discontinuity? Those are places where you have to lift up your pencil, remember? And it does. I would have to lift up my pencil in between here. So I would just say yes. Between x equals 3 and x equals 4 is where you would have to lift up your pencil. Okay? And that should do it for this lesson.